Hi, my name is Langston Wilcox. Today I'll be presenting on Lab 4, Magnetic Field of a Bar Magnet. The purpose of the lab was to measure the magnetic field at various distances from the bar magnet and compare it to the theoretical predictions. We used a magnetometer to collect data, and our results showed that the magnetic field followed a power law relationship with distance. Specifically, we found that the field strength decreased with distance raised to the power of negative 1.06. We also calculated the magnetic dipole moment, mu, to be 5.76 am squared. Interestingly, the observed magnetic field was 8 Tesla while the predicted value was 2 Tesla, indicating some discrepancies we'll discuss later. The magnetic field B of a bar magnet can be described by the given equation. This equation shows the magnetic field depends on the distance r from the magnet and the magnetic dipole moment mu. We also use the Biot-Savart law to derive the on-axis and off-axis magnetic fields, which helped us predict the field strength at different distances. Our system was the bar magnet and the app. Our surroundings was the lab room. Before calculating data, we had to calibrate the app. We placed the bar magnet at one end of the meter stick to position the phone on top of the stick. By sliding the phone along the stick, we located the chip and ensured it was properly aligned with the magnet. This step was crucial for obtaining accurate measurements. Next, we recorded the magnetic field values at specific distances. We found the distance where the net magnetic field was 100 microtesla and recorded it. We measured the y component of Earth's magnetic field using the magnetometer. We set up a second ruler perpendicular to the first offset to measure the off-axis fields. We moved the phone alongside the ruler, ensuring no rotation or tilt, and recorded the x, y, and z components of the magnetic field. We corrected the y component by accounting for Earth's magnetic field and updated our data. We repeated the process to obtain 3 values for each distance and calculated their averages. Here are the results of our measurements. We recorded the magnetic field at distances corresponding to the field strengths of 20, 70, 120, 170, and 220 microtesla. The table shows the average distances and field strengths for each measurement. We also calculated the natural logarithms of the distances and field strengths to analyze the power law relationship. The slope of the line in the log-log plot gave us the exponent n equals negative 1.06, which describes how the field strength decreases with distance. We also measured the magnetic field off-axis by adding a perpendicular ruler at the chip point. We found a point where the magnetic field was 100 microtesla and recorded the x, y, and z components of the field. The data show the off-axis also followed a power law relationship with a slope of negative 1.06, very close to our on-axis results. Using our data, we calculated the magnetic dipole moment mu of the bar magnet. From the intercept of the log-log plot, we determined the constant k, and using the equation given, we found the dipole moment to be 5.76 am squared. We also wrote a code to calculate the magnetic field at a 45-degree angle from the axis. The code used the dipole moment and distance to predict the field strength. The results matched our experiment observations, confirming the accuracy of our calculations. Here's the rest of our code and our diagram. Some potential sources of error in our lab included that the Magneto app could have had calibration issues, misalignment of the phone or magnet could have affected the readings, and if the chip wasn't perfectly aligned, the measurements could have been skewed as well. In the case Earth's magnetic field was not accounted for, the values would be incorrect because Earth's field would skew the bar magnet readings. In the case the magnetic dipole moment was doubled, the field strength would double in magnitude, but the direction would remain the same. In conclusion, we measured the magnetic field of a bar magnet at various distances. We compared experimental results to theoretical predictions, finding close agreement with minor discrepancies. We demonstrated the importance of accounting for Earth's magnetic field to avoid skewed results, and we were provided insights into the behavior of magnetic fields and the application of the Biot-Savart law.